look at even and odd functions. I want to start with even functions. So let's look at what it means for a function to be even. For an even function, we need f of negative x to be equal to f of x. So by changing the x's to negative values, we do not change the function. Another way to think about this is that it's symmetric with respect to the y-axis. We can treat the y-axis like a mirror and it'll look the same on the right and the left. For our equation, changing the sign gives us the same output. So our y values match for positive and negative, which means we'd be symmetric with respect to that y-axis. Next, let's look at odd functions. Odd functions have the property that f of negative x is equal to negative f of x. Changing the x to a negative value changes the sign of the entire function. Odd functions are said to be symmetric with respect to the origin. This means if I look at the graph and I can turn the graph 180 degrees, the graph looks the same. That's what it means to be symmetric with respect to the origin. Let's look at f of x equal to x cubed minus x. To determine if this is even or odd, the first step is to change all of the x's to negative x's. That would make this negative x cubed minus negative x. A negative times a negative times a negative is negative, so this is the same thing as negative x cubed. And minus a negative is the same thing as a positive, so plus x. This is the same thing as negative x cubed minus x or negative f of x. And that tells me that this graph is in fact odd. This is what the graph of x cubed minus x looks like. And the main thing to notice is if I were to take this graph and turn it a full 180 degrees, the graph would look the same as it does here. So this is in fact symmetric with respect to the origin. Next, let's look at x squared minus x to the fourth. This time if I try to plug in a negative x, I get negative x squared minus negative x to the fourth. A negative times a negative is a positive, so this is the same thing as x squared. And 4 negatives would also cancel to give me x to the fourth. And I can see that this is the exact same thing that I started with. So this tells me that this is an even function, since plugging in negative x did not change the function. Here's the graph of this function, and I can see that the y-axis here acts as a mirror, and it's the same on both the right and the left. And that is my indication that it is even, that it is symmetric with respect to the y-axis. Let's look at one more, x squared plus x cubed. If I try to find f of negative x, I get negative x squared plus negative x cubed. A negative times a negative is a positive, and a negative times a negative times a negative is a negative. So I haven't left the function alone. This is not the same as the original function, so it's not even. But I also didn't change the sign. I did not multiply through by -1, so it's also not odd. This is actually neither even nor odd. It is not symmetric with respect to the origin or the y-axis. Here's the graph of this function, and we can see it does lack that symmetry. The y-axis is definitely not acting like a mirror, and if I were to turn this graph 180 degrees, it would not look the same as it does now. So this function is neither even nor odd.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.